Hey, what's going on, guys? We have this question right here. It's asking for the Pratt bridge truss, determine the axial force in member EK. So first of all, EK is right here. So for this kind of question, if they ask any member, we cut this part first and find the direction. So first of all, before I do this, I have to know how many unknown variables we have. So we have force acting on this right here, and we know there are three forces going to act. So let's see. So this is so first of all, if I calculate this one, it will make everything easy. So in order to do that, I have to do, so here's the force acting on this way and this way. So if you see, there's no horizontal effective force acting on this, therefore I can directly say that there's no x is equal to 0, so we don't even have to consider this part. So first let's solve for, to find hy. What I can do is I can take moment around a, moment around a equal to 0, and if I take counterclockwise, I can do like f time l, f time l. This is counterclockwise. If it's counterclockwise positive, this is pushing clockwise. So f minus f time l minus 2f minus f time 2l minus f time 3l. Like, you can do all of them together, or you can find the uh, hy in another way. Like, if you see, look at this picture. Like, if you see, if you cut this part into two parts, it's symmetric because it has the same distance, same amount of force acting on it. So we can say this forces share equally for both of them. For example, if I calculate total force, so they have given F is equal to 340. So we have totally 5 forces. I multiply this 340 by 5, and if I divide it by 2, that is going to be equal to Hy and Ay. We can save a lot of time doing this, so we can say this is symmetry. So that's going to be my answer. And if I do this, it's going to be 100, so 1700. So answer is going to be, wait a minute, so 500, 340 times 5 divided by 2, it gives me 850. So this is equal to 850 kilonewton. So this is the force going to act on both sides. So from this information, first of all, I had to do this, I had to draw this separately. So let's see. So I draw this part. I'm taking this side because this is easier to solve. We have this side too much things going on. So it's, so if I take this one, so I know there's a force acting on it. This is Hy, and we got it positive, therefore it's going to be 850 kilonewton. And then we have this one. Let's assume the forces. We don't have to be sure exactly which direction it's going, because when we find the final one, if it's negative, it means we assume the wrong direction. So we have to find ek. That's the question. So here we have a force acting on it is 340, and here we have force 340. So since this case ek, and we can find this angle right here. If you see, the height is L and the width is L, therefore I can say it's tan inverse L by L. So tan inverse 1 is 45 degree. So we can assume this angle right here is going to be 45 degree. So from, by observing this, you can directly say, uh, you can directly assume which method we can use, because If you see, all of them are vertical forces. Vertical forces are known, and if I take horizontal force, it's so much complicated because we don't know that, right? So we know vertical forces and we know these things. Therefore, we can take the total vertical force, total Fy is equal to 0 in statics, and if I take upside positive and solve for this one, this is gonna be um, okay. This is gonna be ek cos 45, and it's negative. It's acting downward. Minus ek cos 45 degree minus 340 minus 340 again plus 850 is equal to 0. Now if I solve for ek, it comes out to be 240 200, 240 okay 240.42 kilonewton. So this is my ek, and since the answer is positive, I know this is I have assumed right direction. And if you see something like this, two arrows facing each other, like it means the other force is acting opposite to it. So it means it's in tension. For example, if it's opposite side, it means it's in compression. So since we got positive answer, it's acting this side, it means it's in tension. So this is my final answer, and that's the question it's asking. I hope you guys like this video. See you next time.